Okay, so I'm pretty excited about these next two videos I'm going to put out. This is the introduction, and the next one we're actually going to do the experiment that I'm about to talk about. But this is one of my favorite things we do in this class. What we're going to do is we're going to use Monte Carlo simulation, which I posted a video about a little while ago, which you can review. Um, but we're going to use this idea, Monte Carlo simulation, to estimate pi. So just remember, pi is the ratio of a circle's circumference to its diameter. And I think it's pretty incredible that you can use probability and random processes to estimate this quantity. So just to do a little review here before I get into it. Monte Carlo simulation, remember, we're generating random numbers, a sequence of random numbers, and we're treating them as outcomes of some real-world process. So Monte Carlo simulation is a way of simulating real-world events with random numbers. And we've done it a few different ways. We've flipped coins, we've rolled some die, we've generated random numbers on our calculator, which is how we're going to do it today. Well, in the next video, that's how we're going to do it. But this particular experiment, what we're going to do is generate these random numbers and treat them like points in the Cartesian plane, the XY plane. And we're going to think of them as falling inside a square with width 1. So in other words, we're going to generate random numbers between negative 0.5 and positive 0.5 twice. So we're going to get two sets of numbers between negative 0.5 and positive 0.5. And we can think of those as being random points within a square in the XY plane. And then we're going to inscribe a circle inside that square and generate all these points within the square. And then we're going to calculate the proportion of points that fall inside the circle versus the proportion or the total number of points. And that'll give us a way of estimating pi. So with this video, what I just said, it might be a little confusing. So I want to give us a visualization for what's going on so we can actually see what we're going to be doing. And in order to do that, I'm going to draw some pictures in the plane here. So I'm going to make sure I have my window set. And I actually set it before this video, but I just want to show you what I have mine set to. So I have it just a little past negative 0.5 and a little past positive 0.5 on the X side. Same thing on the Y side. And that gets to what I was just saying. We're going to create a square of width 1. So we're starting at negative 0.5 and going up to 0.5 on the X, and same thing on the Y. So that'll give us a square of width 1. So let's go ahead and draw that square. I'm going to go to draw, and I'm going to fudge it a little bit. I'm just going to do some horizontals and verticals rather than drawing the line segments. So I'm going to put a horizontal at negative 0.5. All right. And then quit out of that. And then I'm going to draw a horizontal at 0.5. That'll give us the top and bottom of the square. And then I'm going to draw a vertical rather, at negative 0.5. And then I'm going to draw one more, and we'll have a nice square. 0.5. All right. So now we got a square of width 1 in the XY plane. And the idea here is we're going to generate points within this square. Like we're going to generate random numbers that represent ordered pairs, x comma y, that fall within this square. And then we're going to find the proportion of points that fall within a inscribed circle. So an inscribed circle just means a circle with a radius that touches the sides of this square. So if you think about that, if we have a circle centered at 0, 0, inscribed in a square of width 1, it would have to have a radius of 0.5. So we're going to use the draw menu again, and for this you got to go down a little bit. I think it's number 8. No, number 9. Okay, so we want a circle, and we want to center it at 0, 0, with a radius of 0.5. And then there we go. So now we have a circle inscribed inside a square. And the idea here is we're going to be generating points in the plane randomly. So to show you what I mean by that, we are going to, first of all, recall how we generate random numbers between 0 and 1. That's the rand function. Now there's a problem with the rand function, is it only generates between 0 and 1. Right? We want between negative 0.5 and positive 0.5. So one of our theorems of data transformation is we can just subtract off the mean, or rather we subtract off the amount we want in order to center the mean at 0. So remember, we have a uniform distribution between 0 and 1, and the mean would be 0.5. So if we subtract off 0.5, the mean would now be 0. So in other words, we're essentially standardizing, right? If you recall z-scores and subtracting off the mean and dividing by the standard deviation. I mean, we're not dividing by the standard deviation here, but same general idea, right? We're subtracting by 0.5, and this will give us random numbers between negative 0.5 and positive 0.5. I'm just generating a bunch of them here so you can see what's going on. So what we're going to do in this experiment that I'm going to post in the next video is we're going to generate a bunch of random points that fall within this square. So to show you what we're going to be doing is we're going to be drawing points. So we're going to turn on a random point. So we're going to pass into this point on function, which will turn on a point in the plane, a random number for the x that's centered around 0. Whoops, I meant minus. And then delete. Okay. And then again for the y, we're going to pass in a random number between negative 0.5 and positive 0.5. And to do that, we're going to subtract, if I can hit it, 0.5. Alright, so this will turn on a random point. So notice we got a random point there. So let's execute this a few more times just so we can see that it is indeed filling out some points in the plane. So you see how it keeps creating more and more of them. And notice one in the top right corner, it doesn't fall within the circle. So we have this theorem from class called the law of large numbers, which says if we generate enough random points, we should get the true distribution, the population distribution. And just by geometry, the proportion of points within the population distribution that would fall within this circle, that should be related to pi. And in fact, if you think about it, the relationship there, so the probability of us selecting a point, of us randomly generating a point that falls within this circle, remember the definition of probability. It's the number of ways to get a certain event over the total number of ways. And we've been talking about how you can interpret probability as an area. So if you think about like the area of a circle, that's pi r squared, and you divide by the area of a square with side 1, that would just be x squared or 1 squared. So if you think about the ratio there, it's the ratio of the area of a circle, pi r squared, which r in this case is 0.5. So it's going to work out to be pi 0.25, right? And what we're going to do is we're going to simulate a large number of these points and calculate the proportion of the points that fall within this circle. Because then that sample statistic, the sample proportion, that should, in theory, be related to pi. In fact, it should be 0.25 times pi, right? Like we just discussed. So in other words, if we calculate the proportion of points that fall within this circle from our randomly generated sample and then multiply by 4, we should wind up with an estimate of pi. And that's what we're going to do next video. So what we're going to do, let me just back out of this. What we're going to do is we're going to write a program. So our calculator gives us the ability to create custom programs. It ships with a programming language called TI Basic, which is just a pretty bare bones scripting language, which allows you to save like subroutines and reuse them. So what we're going to do in the next video here is we're going to hit this program button, and so I made an Inscribe program earlier that does what I just showed you, creates a circle and a square and generates some points. But what we're going to do next video is we're going to create a new program. So I'm going to go ahead and create the stub here. That's what it's called, just the blank shell of the program. And I'm going to call this, so we're using Monte Carlo simulation to estimate pi. I'm going to call this Monte Pi. So this is a program that we're going to write in the next video. And before we do that, let me just point out a few things here. This is the program editor. This is where you can create programs on your calculator and save them. And the colon you see there, that means a new line. So if I hit Shift Insert and hit Enter, it'll start a new line, and I can use the arrow keys to shift between them. But this is like a text editor. It's where you can enter the commands that you want to script out. And when you're in the program editor, if you hit the program button, it'll bring up a special menu. So this is the programming commands that TI Basic gives you. So there's this control command, which are like control structures, which we'll talk about next video. And then there's this IO category, which is, IO stands for input output. So this is like displaying output to the user or getting input from the user. All these functions perform operations like that. So what I just want to do is use a very basic one called display, which just prints to screen. And notice when I select it, it puts it into the text editor. So this is a function on your calculator, and the way it works is you pass in what is called a string. So we've been using Python in class, and Python has strings as well, and they're exactly the same on your calculator. Got to use quotes, and I'm just gonna print out Monte Carlo, or Monte space Carlo. Whoops, Shift Inserts, Alpha Carlo, Alpha Carlo. Okay, there we go. And then close the quotes. And so what we're doing here is we're calling the display function and passing in a string of Monte Carlo. And this is a pretty basic program, but it will do something. Let's go ahead and clear all the output here and go back to the program menu. So the first thing you see here is the execute menu, and if you select one of your programs from this menu, notice the one we just created appears here. If you select it and then execute it, notice it prints out, whoops, I gotta execute it again. It prints out the text we passed into the display command. So this is the general idea of creating programs on your TI calculator here. Is you're going to go to the program editor, program menu actually. You're going to create a new program, and then once you've created it, you can go back into it and edit it in the edit menu. So I'm going to select the one we just created, and this is where we will pick up in the next video. We will actually do what we were talking about. We'll generate some random points, and we'll try to estimate pi. It'll be lots of fun. I'll see you there.